they've kind of missed, isn't it? That's kind of my feeling. So I don't know. So guys, we're going to talk about things that are called conditional statements, and as long as we're kind of on this idea of ripping on weathermen and the forecast that they give and not following, we'll say if a weatherman predicts snow, then we won't get as much as they say we will. Okay? Here's what I've said. If a weatherman predicts that we're going to get a lot of snow, what did I say after that? Then we're going to get less than what they predicted. Okay? That's a conditional statement. I start something with if. In science class, do you guys ever do anything like hypothesize something in science class? What's a hypothesis in science class? It's like a guess. It's an educated guess. So it's like tonight. Who do we play tonight, Britt? Old Columbus? Okay. So I'm saying that my hypothesis is that the boys are going to win tonight. Okay, I'm saying the boys will win tonight, but I have to have a conclusion then as to why they're going to win. So I'm going to say the Union boys are going to win tonight because, and then I'd have to list a bunch of reasons as to why they're going to win. Okay, what's my hypothesis? Boys are going to win. Then I need to have some facts as to why they're going to win. I think they're going to win because they're going to play lockdown defense tonight. Something like that. Or I may say Cale Lambie might go off from the three-point arc. Something like that. I mean, he's made like 1 or 2 this year, hasn't he? Maybe 3. Right? Right, Britt? 4? Well, I'd say some outrageous number like 71. Something like that. I think it is 71 that he's made this year, isn't it? 70, that's crazy. Okay? But a lot of stuff that we're going to be talking about today are going to be conditional statements. There's an if part of the statement, there's a then part of the statement. Okay? So here's another conditional example. I might say, if I teach this section, then what can you count on after I'm done teaching this? If I teach you this stuff, what can you count on at the end of this? Hopefully you know how to do it, but Parsons probably going to give you an assignment. Okay? So something like that. Okay? So if Parsons shows us how to do this, then he's going to give us an assignment. That's called a conditional statement. Okay? 9.1 is titled Conditional Statements. We're going to be having a question here. It says, when is a conditional statement true or false? We want to know when a statement is true or false. Okay? Right down here it says a conditional statement symbolizes or is symbolized by, all right, this part right here is very important. You're going to see this right here. Might want to underline that, box that in. That's going to be the type of stuff that you see. What that says is the following. It says this can be written as an if-then statement in which P is the what? P is the what? Hypothesis, and Q is the what? Conclusion. Here's how you would read this then. I'm going to write this right down here by the following. We're going to say P, this is read as P implies Q. Okay? Basically, this is the following. This is really saying if P happens, if P, then Q is going to happen. That's how you read that stuff. It's read as P implies Q. You can also read it as if P, then Q. And I'll tell you what the P and Q stuff means. P and Q are just going to be variables that represent part of the statement. P is typically the hypothesis. Q is typically the conclusion of the statement. Okay? And I think that once we get through the vocabulary and start looking at the 5 examples I want to show you today, I think that this will make more sense. All right? So again, if I say this, if Parson teaches us this section, then he will give you an assignment. If Parson teaches us, what is P really representing? What comes after if? The Y part. If Parson teaches us, okay, what's the conclusion then? Then the conclusion is I'm going to give you a what? An assignment, okay? So P is like the part where if I teach you this, Q is going to be the part that's your conclusion, okay? And in that case, given an assignment. All right, goals for this today. First one, we're going to write what's called a conditional statement. We're going to use definitions written as conditional statements. I'll show you what that means. We're also going to write biconditional statements. That's kind of a tricky one. And then one that's going to be really important to you today is going to be what is called a truth table. what kinds of statements are true, what kind of statements are false. I'll give you the formulas for those and how they come up with that stuff. But guys, a conditional statement, all right? A conditional statement is just basically a logical statement that has two parts. It's a logical statement that has two parts. And the way I think I want to write this today is this. I think I want you to write it down as the following, okay? It's a logical statement that has two parts. It says if, and then I'm going to put right here in words like this. After the word if comes the hypothesis. So there's going to be if something. In this case, the part that comes right after if is the what? All right, something that's going to be written after the word then is going to be your conclusion. And what can you conclude? All right? So understand that that's what a conditional statement is. It's an if-then statement. So in the vocabulary, we jump into the next one right here. Next vocab term, if-then form. It's how a conditional statement is written. It's how a conditional statement is written. So I'm going to put a statement up here. Okay? I'm going to put a statement up here. Maybe if, I like this one. I'm going to write down this one. If today is Monday, then what's that mean about tomorrow? Tomorrow is Tuesday. I'm going to write this down. Then tomorrow is Tuesday. Try and squeeze it in here. Oops. Spelling parson, tomorrow, tomorrow. My girls went to that yesterday, the Annie show. If today is Monday, then tomorrow is, squeeze it in here, Tuesday. I know that's not written the best, but it says if today is Monday, then tomorrow is Tuesday. That's an example of an if-then statement, or a conditional statement, if you will. Okay? In that statement, what's the hypothesis, guys? Today is Monday, because it comes right after what? If. Hypothesis is the part of the statement after what? If. So from this statement right here, what's the hypothesis? Today is Monday. You guys smell that? Kitchen, I think? Smells like they're brownie meat or something. What's the conclusion in that statement then, kids? If the hypothesis is if today is Monday, what's the conclusion in that statement? Tomorrow is?
Oh, that smells like chicken. I can smell that, Calvin. Was that a fart? No.
Glad we got that on tape. All right.
Oh, it smells bad.
Oh, people that listen to this, there's never a dull moment. Never is. All right.
It can't be that strong. There's no way.
I think it must be bacon sauce down in it.
There's no way.
Okay.
Or the chicken in this bag is really
So guys, right here, negation. Negation is an opposite of the original statement. Okay, negation is the opposite of an original statement. Okay. Negation would be if today is not Monday, then tomorrow is not Tuesday. And negation would be if today is not Monday, then tomorrow is not Tuesday. Okay? All right, so it just says the opposite of the original statement. It just says the opposite of the original statement. Okay? Next four that we're going to get into that are going to be pretty important for you guys. These will be pretty important for you. These will be pretty important for you. Guys, the converse. Somebody want to read what the definition of the converse is, guys? Somebody would read that for me. I say I want the converse of that statement. What's the definition of a converse? Somebody volunteer to read that for me. Exchange the hypothesis with the conclusion. Okay? Exchange the positive with the conclusion. Okay. All right. So the way I would write this statement would be the following. It says, instead of if today is Monday, I would say if tomorrow is what? Basically, I'm going to take what's after the then part and put it after if. So in the original statement, it says if today is Monday. We're going to change that with the conclusion part. We're going to say the following. Converse is this. We're going to say if tomorrow, gosh darn, why am I doing that? If tomorrow is Tuesday, tomorrow is Tuesday, what am I going to put after then, guys? Then what? Then today is Monday.
Wait, is that going in the
Converse one. Okay, if tomorrow is Tuesday, then today is Monday. All I did is take the hypothesis, and I left the words if and then alone. And I took the part that's the hypothesis and the part that's conclusion and switched them. Okay? So that's what it means to be the converse. Take the conclusion part of the statement and the hypothesis part of the statement, switch them around. But you do not move the words if and then within that statement. Okay? And we'll look at one here like that again. The inverse. What's it say about the inverse of this statement? Again, we're using this statement right up here from the if-then form. What's it say about inverse? What does it say to do?
negate both the hypothesis and conclusion?
Negate both the hypothesis and the conclusion. So we're going to say, how would you negate if today is Monday? You would say if today is, well, not. You would say if today is not Monday, then tomorrow is not Tuesday. That's what it means to do the inverse right here. It says negate both the hypothesis and conclusion. Okay? So to negate this right here, you would keep everything the same, but you want to change this to being, instead of it being Monday, you want to not be Monday. So I'm going to say if today is not Monday, then tomorrow is what?
Not Tuesday.
So you understand what the inverse is? And tomorrow is not Tuesday. Okay? All right, then you're also going to hear what's called a contrapositive of a statement. A contrapositive of the statement. It says, first of all, write the converse, then what?
Negate.
Okay, so the converse was right up here. Here's the converse of the statement. So if tomorrow is what?
Tuesday.
So how would you negate if tomorrow is Tuesday?
But tomorrow is not.
If tomorrow is not Tuesday. Okay, so this is what the contrapositive of this would be. If tomorrow is, can I abbreviate like this to make room? If tomorrow, I guess I didn't say much room. If tomorrow is not Tuesday, then what, guys? Then today is not Monday. Okay, negate that. Then today is not Monday. Okay, so I think this is going to be really important for me. Watch what I write up here, guys. Watch what I write up here. Okay? A conditional statement in if-then form was like this. It was like the following. We had an if part of the statement, and that implied Q. All right? This is like the original form. This is like the original form. Okay? Now, negating stuff just means a negation. If you have a P, negation means that you would say not P like this. This symbol right here means negated. Okay, so I want you to understand these three right here in terms of symbols. Right up top here, this is original form. This is the original statement. If whatever P is implies whatever Q is, then Q. This says if P, then Q. So the converse of this takes this original statement. What did it do, guys? What did the converse do? Just changes the hypothesis and conclusion. So if your original statement is given as whatever the P statement is implies Q, then the converse of the original statement is then if Q, then what? P. Okay, so you might want to write that down. These are going to be things that are important for you to understand. Okay, an inverse said to do what to both the hypothesis and conclusion of the original statement? What's it say? Negate both of them. So I'm going to negate the P and the Q. So I'm going to take the original occasion, or original statement, original conditional, if you will, and say, well, if this is the original, then the inverse is not P implies not Q. Or if not P, then not Q. That's how you read this. If not P, then not Q. All right, then the contrapositive was to write the converse, which is right here. Q implies P, and then negate. So what's the contrapositive going to look like in terms of P and Q? Not Q implies not Q implies not P. Okay? So those are all going to be symbols that you want to make sure you understand there when you have that within the notes. Okay?
So like the little squigglies are
The squiggly means not. It's a negation. It's like the opposite of what you would say. Okay? It's kind of like a negative sign, but they use that squiggly because that's how you do it with stuff like this. Okay? All right. Equivalent statements. Basically, guys, statements are equivalent when both statements are either true or both are false. When you have an equivalent statement, if they match up. If you have one statement that you say and it's false, and then a different statement in different wording, and that statement is false, and both statements turn out false, they mean the same thing. If both statements would turn out true, they mean the same thing. And I'll show you what that means here in a bit. Okay? A biconditional statement is going to contain the words if and what? If and what? Only if. The thing you need to understand about that is this. This is written like the following. Basically, it means that P implies Q, and then put arrows like that. It also means working backwards. Q would imply P. Okay, so an if and only if has two arrows on the end. I'll show you an example of how they come up with the if and only if part here in a second. I could say tomorrow is Tuesday if and only if today is what? Monday. Okay. I could say tomorrow is, listen to what I say. Tomorrow is Tuesday if what? Today is Monday. I could say tomorrow is Tuesday only if today is Monday. So that's how the if and only if come together. That makes sense? The only way tomorrow can be Tuesday is if today is what? Only if that, right? Okay. And then a truth table, or I'm sorry, a truth value right here, it just tells if a statement is true or false. Okay, it tells if a statement is true or false. And then the last vocab word right here, there's going to be a truth table. And I'm going to write a note here, guys. See the very end of your notes. And we'll get that truth table put together. Basically what it is these are the conditions under which a conditional statement is true. How many of you guys have hypothesized something in science? How many of you hypothesized something in science only to conclude that your hypothesis was incorrect? So what if I say like something like this? I might say something like this. If 2 plus 2 equals 5, let's hypothesize 2 plus 2 is 5. That's wrong, isn't it? Hypothesis can be false. If 2 plus 2 equals 5. I'm not saying it is, but I'm just saying what if it was. I might say if 2 plus 2 equals 5, then 5 times 2 equals 10. Which part of that statement is true? Hypothesis or conclusion? Conclusion. So in this case right here, was my statement true or false? I came up with what I thought I wanted to be right. What I concluded was 5 times 2 is what? 10. If my conclusion is true, do I have a true statement? You bet I do. You bet I do. I do. Because it doesn't matter what you hypothesize. You can always hypothesize something, and if that hypothesis is actually false and you know it to be false, that's okay, because in the end, what kind of statement did you have? True. And we'll talk about what that means here in a bit. Okay? So a lot of vocab, a lot of stuff that you'll want to make sure you understand. Hopefully you got the examples written down. Let's jump into this right here. Guys, example 1, simply rewriting a statement. It says use H to identify the hypothesis and C to identify the conclusion. Then rewrite each conditional in if-then form. Okay? We want the word if and we want the word then in here. That's what if-then form means. Okay? So right here in part A, it says x is greater than 5 if x is greater than 3. Well, what comes right after the word if? If x is what? Greater than 3. So right here I'm going to say the part that's after if, and the part that comes after if all the time is the hypothesis or conclusion. Hypothesis. So above this part right here, I'm going to put an H. That is the hypothesis. So what's that mean about this part, x greater than 5? That part must be your conclusion. Okay? Now, guys, in this original statement, the original part of this statement, did it have the word then in it? Did it have the word then in it? No, it doesn't. So we want to rewrite it so that it does. So we're going to write it this way. We're going to say if our hypothesis. So we're going to say if x is greater than 3, then what, guys? What comes after the word then? Conclusion or hypothesis? Conclusion does, right? So if x is greater than 3, then x is greater than what? Okay. There's your if-then form of the statement. By the way, is that statement true or false? X is greater than 3, then x must be greater than 5. Can you think of an example that would make that statement false? 4 does. 4 is greater than 3, right? Is 4 greater than 5? Not, is it? Okay, 4 would be a counter example. So 4 is what would make that false. Okay? All right, so right here, it looks like the following. It says members of a soccer team. You can be a member of a soccer team if you're a member of the soccer team. Then what's true today, guys? Practice day. I should have changed that to track because the tracksters are going to start running tonight. All members of the soccer team have practice today. What's the hypothesis in this? If you are what? If you are a member of what? If you're a member of the soccer team, then what? What's going to happen to you? Okay, so how do I write that in if-then form, guys? If you are a member of the soccer team. If you are a member of the soccer team, then what, kiddos? Then you have practice when? Then you have practice today. Then you have practice today. Okay? Then you have practice today. So within a statement, can you identify a hypothesis and conclusion? Can you do that? Okay? Once you've identified the hypothesis and conclusion, to write your statement in if-then form, what part comes after the word if? Which of the two parts comes after if? Hypothesis, and which part comes after the word then? Conclusion. All right? Okay, example 2 is actually pretty simple here. Example 2 is pretty simple. Talking about writing a negation. It says write the negation of each statement. So in part A, the car is white. Negate that. What would you say? The car is not white. There's your negation. The car is not white. Okay? How about the negation of it is not snowing? It is snowing. Negation just means opposite, right? That part seems pretty cut and dry, doesn't it? Okay, negating stuff. Can we handle that? Okay with that, kiddos?
So, example one, so hypothesis is after if.
Yep.
Conclusion after.
Yep. Yep. And it says so right here, Taryn. If you go back to your vocab right here, hypothesis, part of the statement after what every single time. Yeah. Okay with that, kiddo?
Yeah.
All right, well, let's jump into this third page, and this is where things get pretty interesting. Really important, example 3. Very important on example 3. Okay. They say, hey, let's write related conditional statements. It says, let P be the statement you are in what? Where are you? You are in New York City, and then let Q be, then you are in the United States. Write each statement in words and then decide if the statement is true or false. Guys, the thing you need to understand is this. If a statement's ever false, you need to have a counter example. Give me an example of something that would make that statement false. Okay? So right here, P. Part of the phrase P is you're in New York City. Q implies you are in the United States. Okay. So we need to write this in words. We need to write the conditional statement. If P, then what? Q. So this is going to be if. What's going to come after if?
You are in New York City.
And I'm going to abbreviate. If you are in NYC, then what's the Q part of this? Whoops, I should have put in right here. If you are in New York City, then what, guys?
You're in the US.
Then you are in the USA. Okay, so put yourself in New York. If you're in New York, you there? You there now? Up here mentally. Then are you in the United States? You are, aren't you? True that statement or false that statement? That's true. That's true. Okay. So let's start switching some things around. I don't know why I wrote the conditional statement. P implies Q twice, so we don't need this. So just get rid of this part. Okay. So let's write the inverse of this. The inverse is if you are not in New York City, then you are. If you are not in New York City, then what?
You're not in the US.
How about that statement? Put yourself somewhere not in New York City.
Iowa.
How about Iowa?
Yeah.
How about how about suite number 59 at Union High School?
Sweet.
This room is pretty sweet, isn't it? Let's see, if you put yourself in this room right now, are you not in New York City?
Yes.
Yes. Are you not in the United States?
No.
So how about that statement?
Yes.
Is that always true or can it sometimes be false? We just proved right now that if I'm not in New York, I'm not in New York City right now, right? So we satisfy this part, right? And if we're right here right now, that means we're not in the USA?
No.
No, we're here right now in the USA, right? So is that statement true or false? It's false because an example would be LaPorte City. You can be in LaPorte City, not New York City, right? But LaPorte City is still in the USA. So what I'm saying is this. In order for a statement to be true, it has to be true how many times? Part of the time or all the time?
Part.
All the time. If something is going to be false, you need to come up with a counter example. And an example that we just proved right here is this. False. You could be in LPC. We're not in New York City, but we're still where? United States. Okay. Now, if I would have said something like Toronto, would Toronto make that statement true or false? True. But any city besides New York City in the United States makes that statement false. Okay? Are you okay with that? Okay, give me another place in the United States that's not New York. California. You could be in California, not New York City, right? That's satisfied. But if you're in California, are you in the United States? So there are places that would make this statement false. Let's talk about the contrapositive of this puppy. It says, if not Q, then not P. So if you are not in the USA, if you are not in the USA, okay, so we can't be anywhere in the USA, then what?
You're not in.
Then you are not in New York City. Okay, so think of this, guys. How about that statement? True or false? Put your place in a
True.
Where are you right now then? If you are not in the United States, where do you put yourself? Germany. You're in Germany. So if you're in Germany, can you be in New York City?
Nope.
No. Now, I don't think there's any New York City any other country, is there? Is there a New York City, Switzerland? I wonder about that now. I could totally blow this up. Somebody who's got a Google? Google for me. Google New York City, or type in, is there a New York City in a different country?
Australia, they're mostly British, what they used to be.
Is there a New York City outside of the United States?
I don't know, it's not in. It just says that New York City is in the United States.
And it also says it's part of the United Nations, like the headquarters of the United Nations.
So New York City only exists in the USA, is that what that's really saying? Okay. So then this statement would have to go kind of a statement then. If you're not in the United States, so you're outside the USA, you cannot be in New York City.
Yeah.
True or false? True. Okay. All right. Again, identifying true false can be kind of tricky, but do you understand how to write the original conditional, write the inverse of it, and the contrapositive of it? Now the one thing I didn't write was the converse, okay, and I probably should have put that right here, but the converse would be if you are in the USA, then you are in New York City. In fact, and we'll come back to that, okay? We'll come back to that. All right, let's talk about using definitions. I have a diagram right here. I want you to go ahead and put A right here, B right here, C right here, D down here, put E in the middle, and then these are right angles right here, okay? Those are all right angles in there. And guys, I want you to look at using definitions. All we're really doing is identifying if statements are true or false in example 4. Identifying if statements are true or false in example 4. Okay? Guys, using the diagram, they tell you the measure of angle AEB is 90 degrees. Okay, look at your measure A to E to B. A to E to B. How many degrees does this have to be? 90, because this forms a straight angle right here, right? If that's 90, that have to make this 90. So is this statement true or false? Is the measure angle AEB 90 degrees? It is. AEB is right here. A to E to B is right here. That is a right angle, so that statement would be true. Okay. Read part B. Give me a show of hands and tell me what you think about that. It says the points A, C, and D are collinear. AC and D are collinear, McKenna.
False.
Why are they false?
Because they're not on the same.
They're not on the same line. Excellent. They don't even form a line. What if I would have said coplanar there? True then? Okay. All right, then guys, the last one is this. Ray AC, A to C, and C to A are opposite rays. Again, opposite rays are the following. You would have a ray that starts at this point, goes that direction, and the opposite ray starts at the same point and goes the other direction. So ray C to A, starting at C and going to A, moving left, and then AC are opposite rays. Well, first of all, do they even start in the same point? No, so if they don't start in the same point, can they be opposite rays? So I would say false here because they don't start at the same endpoint. They don't have the same endpoint. Okay, so if I say, hey, here's a geometric diagram, and from that geometric diagram are some statements. Can you identify whether those statements are true or false based on that diagram? Okay. All right, well then the last thing we'll look at here then is the following page here, guys. I'll back up. Everybody have what they need right there?
No.
Who said no?
Well,
You have it?
go ahead.
Are you sure? Okay. Okay, last example is this, writing what we call a biconditional statement. It says rewrite the definition of complementary angles as a single biconditional statement. So the definition I already wrote for you. It says if two angles are what? Then the sum of the angle measures of the angles is 90 degrees. Now if I would switch this around, in other words, change the hypothesis and conclusion, this is what I would get. I would get if the sum of the angles, and you don't have to, don't write this part. If the sum of the angles is 90 degrees, then the angles are complementary. Okay? I wrote the converse there. I switched the hypothesis and conclusion around. Okay? Guys, is that first statement, if it's a definition, is this first statement going to be true? In other words, if two angles are complementary, okay, then the sum of the angles is 90 degrees. Doesn't complementary mean to add up to 90 degrees? So is that statement true? When I write the converse then, it says if the sum of the angles are 90 degrees, okay, that can happen, then the angles are what? Is the converse also true when I switch that statement around? Okay, so both of these make sense, right? So when we say write a biconditional statement, here's the biconditional statement. Bi meaning how many? Two. Here's the biconditional statement you would write. Anytime you have definitions in geometry, they call us a biconditional. They say something, what's complementary mean? Well, complementary means sum is adding up to 90 degrees. If I would switch that around, it means if the sum of angles is 90 degrees, then they're complementary. Okay? This can't happen unless this happens, or vice versa. This can't happen unless this happens. Okay, so when I use this right here, biconditional statements are going to use that phrase, if and only if. That's what biconditional means. Okay, the first part and the second part, if and only if. That's what biconditional means. There's like a two-part to that, or two things are happening here. Here's what the biconditional statement would be. I would say two angles are what? Two angles are, what's the word? Two angles are complementary.
We need the red part.
Yeah, the blue part is what you need. Two angles are complementary. And then this is where it comes up to the following. If and only if if and only if the sum of two angles is 90 degrees. Okay? If and only if the sum of two angles is 90 degrees. Okay, that's this part right here. This if and only if part makes up what we call a biconditional statement right there, okay? Okay, the last thing I'll take a look at here today, and then I'm going to turn you loose on a little bit of work here as a following. You're going to be asked some questions about truth tables, and you're going to be asked in the end, is that statement true or false? Okay? You're going to be asked if the statement is true or false. All right? So what I'm going to do is this. I'm going to put a P up here. And a Q up here. And I'm going to put your outcomes out here, all right? Okay. All right. There's going to be times when you do stuff. Like, remember when I said if 2 plus 2 is equal to 5? If 2 plus 2 is equal to 5. I hypothesize that. Now, obviously, we know that my hypothesis is what? True or false? I'm wrong, right? Okay, so it's possible that a hypothesis to begin with can be false. But just because I hypothesize something that's wrong, does that mean that I can't get a right answer in the end? Does that mean that? No. Okay, it doesn't matter whatever process of something that you're doing, okay? Here are some outcomes right here. It's possible to hypothesize the following. Is it possible to have a hypothesis that's true and then a conclusion be true? Well, the answer is yes. I could hypothesize something correctly in the beginning, and in the end it is true, okay? Then your final outcome of that statement will be a true statement. I might say something like this. If 2 plus 2 equals 4, if 2 plus 2 equals 4, is that true? Then 6 plus 6 equals 12. Is that true? So is the statement I've given you true? So if my hypothesis is true and the conclusion is true, then that means the overall statement is what? True. All right? I'm just going to give you the rest of these examples here. If you ever hypothesize something that's true and then come up with a false conclusion, if you ever come up with a false conclusion, what would Breitbach or Hemseth tell you in science if you had a false conclusion? Would they give you a good grade or bad grade? Bad grade. Bad grade. Bad grade. Bad grade. Right? So is the outcome then going to be good or bad? Bad. So are you going to get a true outcome or a false outcome? False outcome. Okay. What if you start doing something wrong, but in the end got it right? So what do you think your outcome is going to be there then? True. You bet. Your outcome will be true. It's like saying this. If 2 plus 2 equals 5. No. But I'm not saying 2 plus 2 equals 5. I think it is. And then in the end I say, you know what? Then 2 plus 2 equals 4. Am I right in the end? Yeah. So is my statement technically true? Because I was right concluding what I concluded? It was. Okay. The one that's tricky is this one right here. If you hypothesize something false and conclude something that it's false, if you hypothesize something as false and conclude that it's false, what kind of statement are you actually making? Careful. Think double negative. Think double negative. 2 falses make a positive, right? It's going to be like so true here. Okay? So here's the deal. You're going to get asked questions the whole time like this. If the first part of the statement's a true part and the second part's a false part, they want to know what's the outcome. So if I go true, false, if P is true and Q is false, then what do you get in the end? What do you get in the end? What kind of statement? False, okay. This is going to be highly important for the stuff that we look at and some of the things that we work on tomorrow. But make sure you have that down exactly the way I do, because you will refer to that table a lot for the remainder of this chapter. Okay? All right, I'm going to stop there.